Let's look at a couple more examples here of solving systems using substitution. Here we have the system negative x plus y is equal to 4 and x squared plus y is equal to 3. Again, our first step in substitution is to isolate one variable in one of the equations. And again, you can pick whichever one you want, but always go with the easiest one. I'm going to say isolating y in this first equation would be the easiest. To isolate y, we add x to both sides of the equation, giving us y is equal to x plus 4. I can now substitute that quantity, x plus 4, in for y into my second equation, giving me x squared plus x plus 4 is equal to 3. All right, we can combine some of our terms. We should recognize here that we are dealing with a quadratic. And to solve quadratics, we always want to start off by setting them equal to 0. So I'm also going to move this 3 over to the left by subtracting 3 from both sides of the equation, giving me x squared plus x plus 1 is equal to 0. So now we have this quadratic equation that is equal to 0, and we want to try to solve this quadratic. Unfortunately, this one is not factorable. This is not a factorable quadratic. So if it's not factorable, what's our next best option? The quadratic formula. Yes, x is equal to negative b, right? This is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. You guys know that. All right, so we can plug in this case, our a coefficient is 1, our b coefficient is also 1, and our c value is also going to be 1. That gives us x is equal to negative 1 plus or minus the square root of 1 squared minus 4 times 1, all divided by 2 times 1. Simplifying down, we get x is equal to negative 1 plus or minus the square root of negative 3 divided by 2. So take a look here. The square root of negative 3. This actually gives us an imaginary number. Do we have imaginary numbers on our coordinate plane? No, we do not. And remember that the solution to a system of equations is the intersection point of our curves. So if we are getting imaginary answers, what does that mean? Well, two separate things. One, first off, we just say no solution. And that means graphically that our curves never intersect. All right, if you were to graph each one of these curves, here we have the line negative x plus y is equal to 4. And we have the parabola x squared plus y is equal to 3. Notice that they do not intersect, and because they do not intersect, there is no solution to that system. Let's try another one. Ooh, a word problem. A small fast food restaurant invests $5,000 to produce a new food item that will sell for $3.49. Each item can be produced for $2.16. How many items must be sold to break even? All right, so break even. What does break even mean? The break even point refers to the number of units that must be sold in order for the revenue, R, that's the money coming in, is equal to the total cost, C, that's the money being spent. So where our revenue is equal to the cost. Well, in order to solve this equation, we need to come up with a revenue function. Again, revenue is the money that is coming in. How much money are we bringing in? Well, if each item is being sold for $3.49, we will bring in $3.49 times X, the number of units that are being sold. There is our revenue function. All right, and think about that. If I sell 0 units, I'm going to bring in $0. If I sell 1 unit, I'm going to bring in $3.49. If I sell 2 units, I'm going to bring in twice that value. Okay, so there is our revenue function. We also need to determine a cost function. What is the cost of producing this item? Well, we have this initial upfront cost of $5,000. All right, maybe they need to buy a new oven. Okay, so we have an initial cost of $5,000, and then each item costs $2.16. That means that my cost function, the cost as a function of the number of units, is going to be equal to 5,000 plus $2.16 times however many units we sell. All right, now that we have our revenue and our cost function, we need to find our break-even point. And as we said, break-even means where our revenue and cost functions are equal to each other. So what do we have to do? Set our revenue function equal, there's our revenue function, set it equal to our cost function. 3.49x is equal to 5,000 plus 2.16x. We can combine like terms here by subtracting 2.16x from both sides of the equation. That gives us 1.33x is equal to 5,000, and dividing both sides by 1.33 gives us x is approximately 3,759.4. Now, obviously, we cannot sell or produce 0.4 of a unit of food. So, in order to break even, what we want to do is we always want to round this value up. This means that the company must sell 3,760 items in order to break even. All right. And again, graphically, here I have my two curves. I have my cost function, I have my revenue function. We need to find where those two curves intersect. We did so by setting those two equations equal to each other and solving for x, the number of items or number of units that we wanted to create and sell.